Good good morning, good evening, good afternoon. It's Alex here, and welcome to our um, bi-weekly training webinar. I'm glad to see you, and just drop a message in the comments, like exclamation mark, at symbol, maybe hash or percentage, if you can hear me well, if I'm audible, and if my screen is perfectly visible. I would really, really appreciate that. Thank you. And let's begin. So, I would like to a little bit apologize up front if my voice is a little bit shaky. I have a little bit of a sore throat, and that's why my voice might disappear at some point, but I'll do my best. Right. So, let's talk about today's topic. And today we're going to talk about building the virtual machine images using the OneApps toolset. This one is very important part of OpenNebula that I really would like you to use and to benefit out of that. So, what's in the agenda for today? We are going to discuss what's the OpenNebula ready image, right? What is the OneApps repository, and how to build an image. So that's also what we are going to look at. I'm going to show you, give you some hints, tips, and tricks, and so on. Right. So, what is the OpenNebula ready image? Right. So, how it differs from any other image that you can download. Now, OpenNebula ready images, you can find them in our marketplace as one of the options, or build them yourself. Now, what makes an OpenNebula image the OpenNebula image? There is a layer called contextualization package. So, contextualization package allows you to change the configuration of your um, virtual machine once it's deployed. For example, you can set a password, you can change the host name, change the time zone, run a script, and so on and so forth. So the networking part also is going to be handled by the contextualization package. So whenever you deploy a virtual machine, the MAC address, the IP address, and so on are also going to be configured thanks to that contextualization package. Whenever you will try to change something on the running virtual machine, for example, change the password, right? So you forgot your root password and you suddenly need to access, or you would like to change the secure shell key because you, I don't know, lost yours and you need to substitute one, or yeah, anything else. So that part will be also handled by that contextualization package. So you change that on the running VM, and then the reconfiguration is happening. So again, that small layer is very, very, very important one. Now, as I mentioned before, you can easily go and grab an image from the uh, apps. So that is our marketplace. You can see that there are various uh, services, images, and so on and so forth. So these are ready to use. But what if you are not satisfied with that image, or you would like to add your own customizations to that? So obviously, one of the options is to grab that image, deploy it, make these changes, and then save the uh, disk as an image. So that is that's one of the options. But what if uh, you don't want to go through that hustle. You don't want to actually deploy it, and maybe you would like it to be, let's say, distributed across multiple OpenNebula environments, or you would like it to be more or less standardized. So you you would like to write an instruction, an internal instructions, where you will have the procedures and some specific tips and tricks, some specific things you need to add to an image. So then doing all that through the interface might not be that sufficient, or it may just not fit your use case. Then that's where OneApps comes into the game, right? So because OneApps is the repository with all the tools to build the image as the code, right? So you don't need to even have OpenNebula installed in order to build an image. You can do it from the command line. There are some dependencies that you will need to have, right? So you need to install some small dependencies, and you also need to have the packer. So we are relying on HashiCorp's packer tool to build that image. And but anyways, that's going to be fully as the code. And we have this repository right here. So that is the OneApps repository. And there is a very nice wiki pages. So you can go through and copy pastable uh, installation instructions, right? So what you need to install, and also a link to the HashiCorp official repositories, because they're like the minimum version that you will need to have is 1.9.4. On some older systems, it may not have this version, so keep in mind you need to have this one. But anyways, so the dependencies and all that can be copy pasted from the wiki pages, and obviously please follow the hardware requirements, because, well, at least 8 gigs of RAM, at least 2 CPUs, and KVM acceleration must be there. And also, I would stress out the disk, because it depends on your images, depends on the whatever you would like to build. Sometimes your images may become quite heavy, and you would like to have enough of disk space in order to store your images before they will be transferred to OpenNebula. Right. So that's excuse me for the pop-up. So that's all. That's that repository. You will need to clone it. You will need to install the prerequisites, and that's it. So in that repository, you have uh, a few directories that you need to be aware of. So first one is the Packer directory, and the Packer directory contains all the uh, necessary scripts to build some images. Then we have the Windows contextualization package, then we have the Linux contextualization package, and then we have the appliances. So appliances, will touch appliances in a moment, but consider them as application plus operating system. So that's basically for directories that we should be aware of. Now, with this, you can build different Linuxes, but you also can build Windows. So if you have Windows virtual machines, so you can build your Windows images using the OneApps. So it is um, also doable and possible, but there is one catch. You will need to get some of the dependencies, and one of the dependency would be the virtualization tools, and second dependency would be the Windows ISO. right? So you will need to go to the download center and download the Windows ISO and place it into the ISO directory first. With the rest of the things like the Ubuntu, for example, or Rocky, or Debian, or Fedora, or Alma, you don't need to download the ISO because the downloading of the ISO is baked into the logic of that script, right? So, and then OneApps help you to build, and in the as the output, you will have the image that you can upload to OpenNebula, and then uh, point it point towards that image in the virtual machine template and start to using it. So as simple as that. Keep in mind that something that I always would like to warn about is that the Linux image building is faster than the Windows. So consider the timings as well. As of my experience, the Windows image may take up to 15 to 20 minutes, while the Linux will depends on the number of operations that you would like to run during the building process. It may take like 1, 2, 3, 4 minutes, sometimes 5. So yeah, it depends on how many things you would like to be there. So it's also something that just to consider when you are building that uh, virtual virtual machine image. Right. So then, as I mentioned, we have the images and then we have the appliance. So the appliance directory. What's the difference here? That's quite important. Is what we consider as the just a plain image is the image with operating system, right? So image with the OS can be, let's say, Ubuntu or Alma Linux, and that image is pretty much vanilla. It may have some kind of tools installed. I don't know, for example, Docker or Apache web server or Nginx web server. So something like that uh, can be installed there, but it's still pretty much an operating system with some software. And then the appliance is something more complex. It's when you're running some kind of an application on top of that, and that application must be configurable during the deployment. So one of the good examples that we have ourselves would be the WordPress. So WordPress is pretty much as well a web server, a database, right, and a WordPress files. But when you and you can download it actually from our marketplace and deploy it yourself. You will quickly. So let's just go to WordPress image, right? So let me go right here to virtual machine templates, right? So as soon as you start to deploying this, you quickly can find out that there are a bunch of user inputs there, and that helps me not to deploy a vanilla WordPress, but WordPress pre-configured. So with admin password, with admin username, with the site title, and with the SSL certificate. So, and this is what we could call an appliance. So an application that can be adjusted and configured during the deployment from the OpenNebula web UI. So it may be WordPress application, it may be Mini.io, it may be I know Ray appliance, or I mean, it may be something that you custom build, right? Because it I mean, whatever, right? So it's really depends on your needs and your imagination, I would say. The difference here lies in when you build the custom OS image, you only need to provide the scripts that will be executed during the deployment. So, for example, if we are speaking about Ubuntu, you navigate to Packer, go all the way down to Ubuntu, and here you go. You have a bunch of shell scripts, and these shell scripts are going to get executed, right? So, updating grub, installing the context, configuring the secure shell, and then just garbage collection, and also updating the distribution. So these will be executed once, and then any virtual machine instantiated from this image will always come out with these basic settings, right? Now the appliance would have some kind of a logic, right? And if we go to the same WordPress appliance and scroll down a bit just to show you, right? So what you will have here is basically two parts. So one part will be executed during the installation, and another part, or during the building an image, and another part will be executed during the deployment. So let's take the easiest one, and for example, uh, I have something even more simplistic available. Uh, Let me have a look if I can drop it straight to this. So, so for example, this appliance, right? So in the service install, uh, I have just unpacking some kind of an image, um, running some updates, right? And yeah, that's it. So I've unpacked the zip into a directory. And then I'm just creating a systemd service. While in the configuration part of this, so the service configure, what I'm doing, I'm just creating the config file, and then I'm enabling the systemd service. So as easy as that. So this part will remain static across all the virtual machines that are going to be deployed from that image, right? So not going to change unless I'm going to rebuild an image with some new settings. While the service configure part will be executed each time I'm deploying a new image. And for example, the config file will be substituted with new values. So that appliance logic is what distinguish the uh, plain OS image from an appliance image, right? Both are images, just one comes with some kind of application that is configurable during the deployment, and second one comes just as the plain operating system, and then if you need to adjust it or install something, you're already connecting directly to that virtual machine and perform these actions, or you may have some automation for that. But nevertheless, right. So um, that what differs one from another. But let's just roll a little bit back to our basic operating system images. So as you can see, every directory will be under the packer directory, and that's where you can add a new. For example, you don't want to alter the Ubuntu that we supply, so you can just clone that directory and then create your own. Or again, I think it's quite safe to change the original because you can delete it anytime and clone from the GitHub repository again anytime you wish. Now, under the Ubuntu directory, because we will take Ubuntu as our primary example. So under this directory, you have a set of scripts that are going to get executed during the building process. Then you also have some variables, and you have the main uh, builder logic that's implemented here. So this one has, again, some kind of fine tunings and variables, right? So you may, let's say, resize the disk, because when you create an image, it will come up quite tiny, and by default will be very, very tiny. And if you will try to install something like, for example, Docker into that image, you may end up with having no space, right? No disk space during the building process. So what you may want to is to introduce some kind of a resizement, and set it to, let's say, 20 gigs if you know that your application is going to be rather heavy. So yeah, and that's what you can alter here, as well as if you know what you're doing, then you also can fine tune the format of the disk, the disk image and so on and so forth. But typically, I would say you would like to remain this as vanilla as possible. And what you really would like to tackle is the shell scripts, and add your shell scripts there. So these shell scripts are uh, installing or configuring the system the way you wish. What it can be, I mean, it can be sysctl configuration. It may be something like, my favorite example would be the Docker installation, or it may be some custom other custom security enhancements. Also are very welcome. Now I'm going to build that Ubuntu image, and I'm going to build this Ubuntu image with Docker support. So I just need to create a new file. So that would be, for example, 12 docker.shell. And I need to paste uh, the shell script logic into that docker.sh. So again, it depends what you are going to install, but in my case, I could easily navigate um, to the Docker official guides, and then just copy paste it from there. So then, yeah, so why not? Let me do that. So I will just go very, very straightforward in order not to waste your time. And I will copy from the already existing uh, uh, shell script that I already have. So here's what we got. So we have the plain Docker guide installation. The only thing that I think in the Docker guide, you don't add the -y, so your installation may hung. But what I would like to is obviously to make it fully automated. Okay, cool. So then we just go there. Do we need to alter anything else? No, that's basically it. We don't need to change anything in this case, or maybe, let's also resize the disk, right? So we can say that if I'm building the 2204, then I would like it to be 20 gigs. So just to give me some space when I'm installing Docker, because it may consume a bit more disk space that initially uh, I've planned. Right. So that's pretty much it when it comes to building the Ubuntu. So I just need to run make Ubuntu 2204. Where this name comes from, the name comes uh, from the makefile, so from the makefile config. So these are the values that you can use, and if you are going to create your own services, for example, or your own specific images, then you will need to alter the makefile.config and uh, add your image name so you can start the building process. So yeah, that's it. Let's just run make Ubuntu 2204 and we'll see how it goes. So as you can see, slowly taking off, and now we are starting to build. Now the whole output or any error that you may face during the build will be outputted to the to shell. So again, in case something happens, you always can scroll up and try to figure out what happens. In my cases, majority of my fails were due to not having the disk properly sized, and uh, that was uh, my typical issue, right? So um, the first step, obviously, we are retrieving the ISO file, and by default, we are retrieving the ISO file from the internet, but you can point it to something local. So what you can do, you can download uh, the ISO or the image file if it's a cloud image, and then uh, place it directly onto a disk, and then point to that instead of uh, going through the download. But still, it's not the biggest issue in the world, especially if you connect it to the internet and you have a pretty much uh, a fast internet, then uh, downloading a small image is not a problem. Okay, so you can see that right now we went into the downloading the Docker and installing the Docker. So uh, as I mentioned, then every output is visible, so you can follow the uh, follow the output. And in case you need to troubleshoot, you will be able to troubleshoot. Now, where you can find an image once an image is built, right? So you built an image, but then you need to download this image or maybe to upload it, right, to OpenNebula. So every image that you will build will end up in the export directory. So here it is, the export directory, and this export directory will contain that image. Now, when it comes to services, if you either would like to rebuild the service that we already have or build your own service, then your service, your application, your appliance uh, will depend on an operating system, anyways. So for example, if you are building the WordPress, then WordPress will depend on some vanilla operating system beforehand. So in this case, you are going to build the OS first, and then you will need to build your service, because in by default in the logic, the let's say the WordPress will look into the export directory for the correct for example, Ubuntu 22.04 image. Then we'll take this image and we'll build yet another image, but already with that application on top of that. So doesn't matter what you're going to do. You're going to build a service Ray or service MiniIO or just a plain Ubuntu or plain Alma. You will need to have that OS first, right? So everything starts with the OS image, and then either you take this OS image or you will proceed with building a service on top of that. Right. So it is there, right? So it's under the export. You can find that Ubuntu 22.04 is there. So this one is already a usable image. There was no errors, so I can just go there, upload it to OpenNebula. Since I'm running everything on my on the same server, so for me that would be that's going to be pretty much easy. So I will just take my Ubuntu 22.04 image, will place it to our TMP 1. I'll change the ownership to that, right? And then I'm going to log in as one admin, navigate to that directory, and now I can just create an image. So that will be one image command, create. So then -d, which stands for the image data store. Remember, in OpenNebula, we have multiple data store types. Now, when you upload your image, it must be uploaded to the image data store. And then you can use the ID. So I'm using the data store ID because, again, in my case, if I go to data stores, I'm using in this for this demonstration, I'm going to use the default data store, and default data store has the one as the ID. So, okay, then I need to name my new image somehow, and please note that the name must be unique. So that would be Ubuntu 22.04, and then today's date, which is 2025. And then path, right? So path and then path to my file. So obviously, with the path, you can also, instead of the path on the local host, you can also use, I know, some kind of a share or whatever. Just make sure it is accessible and readable and so on. Alternatively, you can download this virtual machine image to your computer as the example, and then use the OpenNebula image creation wizard and upload it from your computer. So it also possible, again, depends how you do it. For me, that would be easier to just proceed with command line because it's everything is installed on the same host. That's it. My image got an ID, the ID of 89, and then I can go to the images section in OpenNebula, and I'll be able to locate my Ubuntu. So yeah, it's ready, so I can use it, right? So I can go to the virtual machine template. So for example, find the Ubuntu 22, right? So this one, update it, go to an image, and attach a different image. Obviously, we can connect it to some kind of a network. For example, this one. And that's it. So now this one is even usable, right? So instantiate custom Ubuntu. And off we go. So the virtual machine is in the process of deployment and will be deployed promptly. Now, as easy as that. So with Windows, there's a bit of a tricky thing, right? So as I mentioned before, you will need to have that. You will need to have that ISO placed in the correct directory, right? So as you can see, I have multiple ISOs here. Also, you will need to have the virt.io ISO, so the virt.io drivers. So you will need to download them and place them manually. Again, we have this in the we have all the links in the documentation, so feel free to use that. And then there is one a small trick that I would like to tell you about, and this is you can find it under the auto unattend, right? So that is the Windows thing to automatically configure the Windows machine. And the thing is that under the product key, you have this directive, right? So you have this thing called key. Now, if you will leave it like that, you will be able to build Windows 10 and Windows 11 image, but you will not be able to automatically build uh, the Windows Server image. If you would like to build Windows Server, you need to delete this directive, right? And keep it empty. So this is something related to Windows and how Windows treats the auto-unattend file. uh, but yeah, obviously that is something to keep in mind. Oh yeah, so we also have something in the chat. You need to change the Packer-Qimo plugin version to something else than 112. Thanks for letting me know. Um, well, probably you're right. Is that I'm using the evaluation ISO, but well, evaluation ISO can turn into a proper server once you enter the product key. So anyways, it's just something to keep in mind that yeah, if you're using the evaluation ISO, then you need to remove this key um, from the auto unattend. Otherwise, you will end up without the properly built Windows Server OS. Now, so the next, but again, if you will remove that, then your evaluation ISO will be built without any issues. But it's going to take some time. So Windows Builder is slightly slower than the Linux Builder. So Linux would be a bit faster. Right. So another thing is when you're building your Windows, sometimes, for example, for troubleshooting purposes, you may want to connect to your virtual machine while it's in the process of building. So by default, we are running KVM. So as you could see in during the building process of the Ubuntu, then it spins the VNC, but this VNC listens on 127.0.0.1. So if you listen on a remote, so if you're running it on a remote station, then there is like a high chance, a high probability that you are not going to be able to connect to that VM. And the biggest problem is that you may not actually find what's wrong, right? Because the Windows is not outputting into the standard output. So you can change that, and it is again, it's changeable. So what you will need to, so how you can do that, it's quite easy, right? So on the somewhere here you will need to add a few things. So the bind VNC address to something like 000, right? To allow it to listen on all the IP addresses. And then you also can set the custom VNC port if you don't want to take it all the time from the output, because otherwise it's going to be a random port. You may force it to be something in a specific range. Or since I'm not building a lot of things and I'm not running a lot of VNC stuff from time to time, I can set the VNC port min and the VNC port max to the same value. So then it always going to be 7777, right? And yeah, so uh, that is the uh, that is the hint. So you can connect and see how it goes. Obviously, that's also true for the Linux host, Linux images. When you build a Linux image, then you can use that instead of uh, just a local host. So you can connect and observe what happens with your virtual with your image during the building process. But as I mentioned, I find it more useful uh, on Linux. On Windows than on Linux. Right, and then you obviously need to point out uh, to your ISO files, because if you will go to the variables auto pkvars, then it may have not the correct ISO file, and the name differs. Right, so you need to point to the correct ones, the ones that you've downloaded. So I'm going to take a copy of mine, right? So just to make sure that I'm using the correct images, like for example, this one, Windows 10, 64, or in case of server 2022 or 2019, that it also points out to the correct Windows ISO file. You also can add some more stuff. For example, set the language to the correct one, especially if your image is a single language. So then it's going uh, to have a little bit of fun, because it will error out uh, when you try to build a Windows image. Then the language mismatch, and then it just stays there without closing the builder. Again, that's when VNC may come pretty handy. So the second thing, obviously, is another is that, for example, by default, it disables the administrator, but you may want to have this administrator, so you can set disable administrator to false, right? So that is one of the options. All right, so I've pointed to the correct ISOs, right? So then we can try to start a builder. Again, we probably not going to finalize it because it takes a little bit of a time. But anyways, at least we would be able to observe the process. So again, same stuff. Let me go back to OneApps. Again, log in as root user and then make Windows 2019. And then we can take, example, Windows 2019 standard. Let it be this one. And here we go. So we started. We can see that the port 777 is now open. So I can use my VNC in order to connect and see whether the thing is getting built correctly. So let me open the VNC viewer. Okay, so as you can see, the Windows now is in the process of getting installed. So typical thing that otherwise you would need to do with your hands now is automated. And then the important part of the contextualization package that we have is also going to be installed. So when you will upload this image into the OpenNebula, you can configure the network settings and other cool things that you can do on Linux. You will be able to do on Windows, like setting the passwords and so on and so forth. Now, when it comes to contextualization, I would like to just highlight that there are some options that are exclusive to Windows, and then there are some options that are exclusive to Linux. So keep that in mind. Not every setting works on both of the operating systems. Right. So as you can see, the process is there. So it just takes a little bit of time in order to finalize it. And then it's going to wait for shutdown. So um, yeah, so once the all the settings and all the configuration is coming to an end, then the uh, builder will shut the operating system down, and then it also going to get placed to the same directory under the export. You will find your Windows image that you can upload very the same way as you upload the Ubuntu or any other Linux image. So, but it's waiting for this shutdown. So again, if it's hung, then using the VNC, you can check out what is wrong there, right? So that's why I find it quite useful to be able to connect and see what's happening there or interact with the operating system should you need to. Other than that, it will automatically going to shut down and you will find your image in the export directory. Yeah. And obviously that would be almost the same with the appliances. But with the appliances, what you will need to do first is obviously create a dedicated directory for your appliance, and then place a shell script with your logic of of your appliance there. So again, you may have different ones. You may install your custom service. You may take any popular app and turn it into the appliance. So it's totally up to you what you would like to see there. Just make sure it follows the same style as our predefined, pre-configured appliances. So when it comes to the script itself, you can write it using shell, or you can write it using Ruby. So whatever is your preference, feel free to use that. Now, if you'd like to have some kind of an example, you can actually use the WordPress as the example, and then just clone this directory under the packer, and then clone this directory under the appliances. Uh, and yeah, you can modify this. So instead of just writing everything from scratch, you can just leverage what we have there. The key difference would be is to make sure you substitute all the references to the correct ones, because inside of the uh, WordPress packer script, you'll find that first thing first, it is referencing the already built image, right? So if you're planning yours to be based on Ubuntu or on any other operating system, then you need to substitute this one first. Second thing, you can see that it is using the WordPress as the reference directory and so on and so forth. So what you would like is obviously to reference yours. So make sure to uh, place it correctly. And last but not least, if you're using something custom, like your custom service, make sure to add it to that make file. So for example, I know the service that I've recently built is the Minecraft, so service Minecraft. And then I can call make service Minecraft. And if all instructions correct, then these are going to get built without any issues. Right. So that is uh, quite an important thing. So again, I would like to stress out that you're supposed to build the operating system first. And if you made any adjustments, but you in under the export directory, you already have this image, then this image is not going to get rebuilt. So if you'd like it to be built from scratch, then move it to a backup directory or delete it from the export directory, and then it's going to rebuild the virtual machine image. So as easy as that. So as you can see, Windows is still in the process of running all the scripts. So as I said, it really is much slower than the Linux, but eventually it will be built. I think it's going to take around like 19 minutes or so in order to build the Windows image. And then, yeah, you upload it, hook to the template, and then deploy the Windows-based virtual machine. And going back to our custom Ubuntu 2204, let's see whether I can log in. But hey, I cannot, right? Because I don't know the password. Well, that's where the things comes very handy, right? So we go to the configuration, we go to update VM configuration, to the context, right? And then we set password to, let's say, OpenNebula. And this will trigger the reconfiguration. So the contextualization package will kick in and will set the correct password. So that's where, again, our configuration is pretty handy. And there's much more that what you can do. So in our documentation, you have a huge set of variables that you can fine tune, and how you can reference to the user variables, how you can reference the template variables to, let's say, set the custom host name. So quite a lot of cool stuff can be achieved using that custom uh, this VM configuration. All right, so let's try to log in. Open Nebula, and I'm in. And let's do ps -a, and we can see that uh, Docker is indeed installed. So as easy as that. Meanwhile, Windows still in the process. So as I mentioned, it is going to take some time. Right. So use it, benefit from that, make it yours, make it uh, adjustable. And yeah, the cool thing that if you store it, then you can easily copy it across multiple OpenNebula environments, or yeah, use it as the base for your appliances. So, do we have any questions? Okay, I can see that. Look at you added a lot of comments. Thank you for that. Yeah. Obviously, you can also use change the headless to true. Oh, cool. Thank you so much. Anyways, any questions from our community? Don't forget to follow us on the social media. Don't forget to attend other awesome webinars that are delivered either by myself or my colleagues. Sometimes they are about the functionality, sometimes that would be a sneak peek of the upcoming functionality. So, yeah, that is something that we all can benefit of. And join our community if you have any issues. It's very highly likely that someone else already had solved that, and you can find that solution in our forum. Or if nobody faced that and you're the first one, well, then you can ask for help. Or if you know how to solve it, then you can actually create a post on how to solve some kind of an issue that previously was unresolved. Right. I don't think we have any questions from the chat. So then I would like to say thanks for attending. Um, I will see you next time, same place, uh, almost the same time. The date would be different. And thanks for joining in. Stay tuned. Bye bye.